three frequency bands which is allocated for the 5G spectrum. This is decided by the International Telecommunication Union. And there are three bands. One is called low band, that is called sub-gigahertz band, around 700 megahertz bandwidth, which is mostly used for the rural area applications. Another band is FR1 band, which is used for the urban and suburban application side, which starts the central frequency of 3.5 gigahertz, mostly voice communication and a little bit of data you can access it. And whereas in 5G, the FR2 band in 5G, the millimeter wave band around 28 gigahertz is opted, and this is mostly for the high capacity and high data rates and low latency where the mission critical services are required. Like stadiums and kind of dense urban areas and all. So when it comes to the network architecture of base station evaluation from 1G to 5G, generally all generations the network architecture will be same, but the difference is from the central office to the data center, and this core network you call it as a backhaul, and from the central office to the tower and the antennas and the radio remote heads, the baseband units and all, we call it as a front hall. So here, generation to generation, the baseband units and remote radio heads and antennas will be changing from the generation to generation, as well as the size of the antenna and the system complexity also gets increased. So for the tower, each generation the name is defined here like this. In 1G you call it as a base station. In 2G you call it as a base transceiver station. In 3G you call it as a node B. In 4G you call it as a E node B. And whereas in 5G you call it as a next generation node B. So this figure is to show, if you see it here, it starts from the second generation, third generation and fourth generation, and this is the fifth generation things. And these are the antennas. As frequency increases, the antenna size automatically comes down. That is as per the theory, lambda is called C by F. So if you see it here, in 2G you have a baseband unit, radio remote heads will be, and along with the BBU and the RRH, the core network is also sitting on the ground floor, and this is a tower, and this is your amplifier to give an amplified signal to the antenna, and this is a traditional antenna for 1G and 2G. So from here to here, this blue color line is a coaxial cable. So coaxial cable is, since coaxial cable is a lossy cable, so you cannot run for meters and meters. So if you start running it, like for the 2G and 1G and 2G, you don't have other options. So you are running the coaxial cable from the ground station to the antenna. So next to the 3G and 4G, to avoid this cable losses and all, at least they have terminated this coaxial cable with the fiber optic cable, and then radio remote head is shifted onto the tower, and then finally the antenna always needs RF signal, so RF cable is required. So RF cable is used in the configuration. Whereas in 5G there is a biggest challenge is there. Everything, including the baseband unit, radio remote heads, and the antennas are clubbed in one small single box. So the taking entire thing on a tower, it's like a massive thing. Since the frequency is higher, the size of the antenna and other things also smaller. But when you are making in a compact size, then the other problem comes like called thermal issues will come, because when you are making the RFICs and the chips and power amplifiers, huge power will be generating in terms of heat. So like that, there is in the company called AT&T, they have launched the 5G base station in the US, and their base station got burned because they didn't take care of the thermal analysis, thermal issues and all, and their base stations got burned. And this is how generally when you see the near to your home or some towers looks like this, and this is your entire cell. The box is shifted onto the tower, means the tower has to withstand that weight. So for that case, the designer challenge here is, the designer has to think about that it has to be very compact and lightweight. That is the major challenge over here. And another thing is that you have to take care of the the heat and other aspects actually. And this is the 4G to 5G the differences. In a base station, in a 4G you have the things are there in the, some of the things are there in the tower and some of the things are there in the ground floor. And here in a 5G, except the core network and digital unit, everything is shifted onto the tower. So the complexity lies here, and the compactness is another challenge. So inside the base station antenna, combining the baseband unit and the radio remote head, this is the architecture inside the antenna looks like. So there is a major difference between the 4G and 5G. Generally, if you ask what is the difference between 4G and 5G, the 4G you have sectoral antennas will be there. Each sectoral antenna will be with a beam width of around 65 to 70 degrees beam width. So to cover 360 degrees, the few number of antennas will be used it. But in a 4G you have the continuous radiation in that particular sector. But this network doesn't even bother if the user is there, then it is fine. And if the user is also not there, then it is the continuous transmission and the AM exposure will be there in that particular area in that sector. So that way the power wastage and